But we're not really going to talk much about doing this inverse part. Instead, we're going to talk about how the Fourier transform shows you what's going on in frequency. So suppose I have a function, and here's a function, and suppose this is this noisy signal. I want a nice smooth version of it, right? So how might I do that? Well, we've learned before that you might blur it with, let's say, a Gaussian kernel. Okay, and what does it mean to blur it with a Gaussian kernel? We're going to convolve the underlying image with that Gaussian. But it turns out the Fourier transform of a Gaussian is a Gaussian. All right, and that's what this shows here. So the Fourier transform, if this is h of x, this is h of u, it's another Gaussian. But you'll notice that here it's over sigma squared, and here it's times sigma squared. Okay, and that's what this is trying to show you here, is that if I have this Gaussian kernel with a variance sigma squared, that I get a new Gaussian, and I apologize, this is an awfully drawn Gaussian. I get a Gaussian whose variance is 1 over sigma squared. Now, if you think about that, that makes a little bit of sense, right? First of all, let's think of a really, really skinny Gaussian, all right? Like almost an impulse. Remember, when you convolve a function with an impulse, you get back the original function? So that means you basically keep all the frequencies. So if my kernel was a very tight little Gaussian, I would expect to be able to keep all the frequencies. There you go. I expect to be able to get almost all of the frequencies back. Likewise, let's suppose my kernel was really, really fat, blurs the heck out of everything. Well, then I would expect to get hardly any high frequency and only to get only the low frequencies. And that's why the Fourier transform, that's one way of thinking about that. The Fourier transform of a fat Gaussian is a skinny one, and the Fourier transform of a skinny Gaussian is a fat one. Remember, they go back and forth. All right. So what's going to happen when we blur this function with the Gaussian is we're going to multiply its Fourier transform by the Fourier transform of that Gaussian. And what it's going to do is it's going to keep the low values and it's going to lower down the higher frequencies. It's going to reduce the higher frequencies by doing that multiplication. And we say that that means that it attenuates, that's the word we use, it attenuates the high frequencies.